Day 701 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2075, Decode the Slanted Ciphertext. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. A string original text is encoded using a slanted transposition cipher to a string encoded text with the help of a matrix having a fixed number of rows. Original text is placed first in a top left to bottom right manner. The blue cells are filled first. Sorry, y'all. Let me do it here so y'all can see the colors. The blue cells are filled first, followed by the red cells, then the yellow cells, and so on until we reach the end of original text. The arrow indicates the order in which the cells are filled. All empty cells are filled with a blank space. The number of columns is chosen such that the rightmost column will not be empty after filling in original text. Encoded text is then formed by appending all characters of the matrix in a row-wise fashion. The characters in blue cells are appended first to encoded text, then the red cells, and so on, and finally the yellow cells. The arrows indicate the order in which the cells are accessed. For example, if original text equals a string cipher and rows equals 3, then we encode it in the following manner. So we would go SIP, then we come back up HER. So you see how it's going diagonally from left to right, but it's going diagonally. Then it says the blue arrows depict how original text is placed in the matrix, and the red arrows denote the order in which encoded text is formed. In the above example, encoded text equals the string CH space IE space PR. The encoded string encoded text and number of rows return. Given the encoded string encoded text and the number of rows return the original string original text. Note, original text does not have any trailing spaces. The test cases are generated such that there's only one possible original text. All right, y'all, so I can understand how that may seem a little bit confusing at first, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. Or not even anyway, let's take a look at these examples because it was real confusing just reading the problem. So in example 1, our input encoded text equals a string CH space IE space PR. Rows equals 3. Output is the string cipher. It says, explanation says, this is the same example described in the problem description. Boom. So this is the same problem, the same example that they gave us, right? But they're going to give us this string encoded text. After we get this string, when we line it up like this, it should read cipher, right? And that's after we decode this text, it should read cipher when it's read like this, right? Boom. So just in case that didn't make sense, let's take a look at example 2, where it's a brand new example. So in example 2, our input encoded text equals a string IVEO space EED space L space TE space OLC. The rows equals 4. The output is I love LeetCode. So I'm going to tell y'all why these spaces are important before we get into the explanation. Because as you can see, this obviously spells I love LeetCode after we put these words into the matrix. But let me show you how this actually works. So this is the first row right here, right? Should have 2 spaces. These are blank spaces. So IVEO space, that's the first row. Then the second row is space EED space. So that would be right here. Space EED space. That's this row right here. Then this row would be space L space TE. So once again, we have space L space TE. So that's this row. Then finally, the last row is space OLC, which we had space, 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 OLC. So that's just an example of how this string is broken down into this matrix. And we know how we're going to break it down by the number of rows tells us how many spaces or we will need on each one of these rows, or how many columns, we'll need, right? And in the end, once we plug this in, because it could get tricky with the spaces though, to know how many spaces go on each row. I just wanted to show y'all that so y'all could just better see what's going on. But once we plug this into the deciphered explanation, says the figure above denotes the matrix that was used to encode the original text. The blue arrows show how we can find original text from encoded text. So once again, once we just put these into the matrix properly, it will spell I space love LVE right here space LeetCode. Boom, just like this. And we want to decipher this right here, this string, so we to know that if we put this in a matrix with 4 rows, then the output will be I love LeetCode. Boom. So just in case that didn't make sense, let's take a look at example 3. Example 3 is a little bit easier to understand because there's only one row. So in this case, the input encoded text equals a string coding. There's only one row. Rows equals 1, so the output is coding, right? There's only one row, so we know that this whole coding needs to fit into one row. And after it does, the output will still be coding. Explanation says, since there's only one row, both original text and encoded text are the same. Boom, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution's not that bad. Now, first thing we need to do is we're going to handle an edge case. If rows is 0, then we could just return an empty string. So we could say guard rows is greater than 0, else open up the brackets, open up the brackets, and we can return a blank string like this. Boom. Then we're going to convert the string into character array for big O1 indexing. So we'll come underneath this and we'll say let chars equal an array, open up the parentheses, and encoded text. Boom. Then we're going to compute the number of columns in the grid. The encoded text is assumed to be written row-wise in a grid. So come underneath this, we'll say let calls equal chars dot count /rows, so divided by rows. Boom. Then we're going to decode by reading diagonally, and we're going to start from each column in the first row, then move diagonally down right. So we're going to say let decoded colon, open up the square brackets, character, come outside of that, we're going to say equals, open up the parentheses, 0, ... less than, calls, come outside of that, we'll say dot flat map, open up the brackets, we'll say start call in, come right here, and we'll say zip, open up the parentheses, O ... less than rows, comma, start call ... less than calls. Come outside of this parentheses, say dot map, open up the brackets, we're going to say R, comma, C, N, and we are going to convert 2D grid positions R and C into a 1D index by coming right here, and we'll say chars, square bracket R, times calls plus C. Boom. Now we're going to remove trailing spaces from the decoded result and reverse the drop leading spaces and reverse back. So we'll come underneath this and we'll say let trimmed trailing equal an array, open up the parentheses, decoded dot reversed, put the parentheses dot drop. Well, let me clean this up so y'all don't get confused. Dot reverse dot drop, open up the parentheses after drop, and we're gonna say while colon, open up the brackets, $0 equals a string with a space, so equals a space. Then we're gonna come right here in between these two parentheses, bring that one down, come right here, and we are gonna say dot reversed again. So dot reversed, boom, and put the parentheses, boom. Then we need to convert the character array back into a string. So we could bring this back all the way over here. Then we'll come underneath this and we'll say return string. Open up the parentheses and we'll say trimmed trail. Y'all, boom. That should be all that she wrote. Let's give it a run. Make sure it runs properly before we submit it. Cannot find trimmed. This should be trimmed, not trimmed. Let's run that again. See if that does the trick. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 243 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, y'all, make sure you get one more look at the code. One more look at the code. And yeah, y'all, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.